All right, in this video, we're going to be reviewing for our test over rational functions. So we're going to be doing a set of practice problems from AP Classroom. This is a lot of questions from the personal progress check, but just the ones that are relevant to what we're doing in our class right now. So as always, these are problems that are related to what's going to be on the test, but what's actually going to be on the test you could see more clearly by looking at the quizzes. So the function p models the population of rabbits on a farm is given by p of t equals this for t greater than or equal to 0. T is measured in months and start of the year. Which of these describes the population of the rabbits as time increases? So I think what we're talking about here is like the limit of p as t approaches infinity. Yeah, approaches a value. So what I'm going to do is I'm going to consider the limit of this thing as t approaches infinity. Okay, so 200t over 1 plus 5t. And, if I'm looking for end behavior, which I know I am if I'm letting x run toward, t run towards infinity, I'm going to take the leading terms and divide them. That's 40. So I'm going to say, all right, population increases and approaches a value of 40 rabbits. We don't see anything else talking about 40, so we don't really have to worry about whether it's increasing or decreasing. I'm not totally sure how you're supposed to figure that out, but maybe with a sign chart or something. Number 2, r is given by this formula. What are all solutions to r of x is greater than 0? We like that. Okay, we're interested in solving the inequality x minus 3 over x plus 5 is greater than 0. So the first thing is we need to identify our key numbers. Okay, we'll have x equals 3, the zeros of the numerator, and the zeros of the denominator. That'll be x equals negative 5. Okay, we're going to make a number line, and we're going to label it with our key numbers. Negative 5 here, 3 there. We're going to choose a test point. I'm going to choose x equals 0. And I'm going to say, all right, when x equals 0, I'm going to have negative 3 over positive 5, and that's a negative number. Okay, so I log that that's negative. Okay, the other intervals, well, I think about the multiplicity of the 0 of the numerator at x equals 3. It's a single root, so I'm going to see a sign change. X equals negative 5, that's a single root of the denominator. I'm also going to see a sign change. Okay, so in conclusion, and I know since it's a strict inequality, I'm not interested in these places, whether they're vertical asymptote or 0. I don't even care because I'm not going to include them either way. I'm interested when this is greater than 0, so this is x is greater than 3 or x is less than negative 5. So that would be answer choice D. The next one's talking about the zeros of a rational function are negative 4 and positive 3. So we're expecting to see x plus 4 and x minus 3 in the numerator. Okay, so that's going to be eliminating answer choices A and D. Okay, because we need zeros, they come from zeros in the numerator. Okay, now we're also probably going to need to make sure that neither of these factors are repeated in the denominator, because if they were repeated in the denominator, we would have a whole or potentially a vertical asymptote if the repeat in the denominator had extra multiplicities. Okay, so yeah, I see this one has the repeated x minus 3, so it's going to be B, okay, because that's the only one that has x plus 4 and x minus 3 and isn't going to simplify off to kill off one of those zeros. All right, now this next one, this is interesting. The graph of the rational function r is shown below. Which of the following tables could be used to describe the asymptotic behavior of r at x equals 1 and negative 1? Okay, that makes a little more sense. I thought they were talking about the end behavior, because it looks like, looks to me like we've got a slanted asymptote going right there, but I thought that might be a little much without a formula, but I think that this is pretty clear to see. As x approaches negative 1, maybe I'll do that one in blue. So I approach from the positive side, I'm approaching positive infinity. So negative 1 from the positive side is positive infinity. That's wrong. Okay, so negative 1 from the positive side, positive infinity, negative 1 positive side, positive infinity. The approach is 0. No, definitely not. Okay. Okay, next. Yeah, on the negative side of negative 1, I'm going down here to negative infinity, and so that one's wrong. So now I'm sitting on, it's definitely D, but I should probably verify with the other vertical asymptote. So we'll go over here and draw that in at x equals 1. As I approach 1 from the negative side, I need to see positive infinity. So 1 from the negative side, positive infinity, that's right there, that's good, that's what I was expecting. And as I approach from the positive side, r of x is approaching negative infinity, that's what I'm seeing there. All right, I'm very confidently choosing answer choice. Whoops, you could not see that the whole time. Okay, hopefully you were looking at this on your own sheet of paper, your own copy of this problem set. But there you go. Okay, D is the right answer, and it's got all the right limits. Okay. Which of the following functions has the same end behavior as r of x equals this function? Okay, well, end behavior means grab the leading term from the numerator and denominator. It's really small. And I've got x squared divided by 2x. And that equals x divided by 2. So what we know is it's a linear function, half of x, y equals 1/2 x. Oh, this is a little tricky, right? Because f of x equals 1/2, that would be, if we had like a horizontal asymptote, y equals 1/2. If we had x squared over 2x squared, we would be seeing 1/2. Y equals 1/2, that's a horizontal line. This is not y equals x divided by 2. Y equals x divided by 2 has a positive slope, it would look about like that. Maybe my scale's a little off there, slope's a little steep, but all the same, it would have the same end behavior. But what we do know is that y equals x over 2, so what I'm saying is r has a slanted asymptote parallel to the graph of y equals x over 2. Y equals 1/2 x is what we're looking for. So something that has the same end behavior as y equals 1/2 x is going to be y equals regular 1x. So I'm going to choose that one. Negative x won't have the same end behavior because it tilts downhill. X squared doesn't have the same end behavior because both edges of it go up. 1/2 is a constant. Kind of already talked about that. Let's keep going. All right, so now we've got f given by numerator over denominator, where n and d are polynomial functions. The degree of n is less than the degree of d. So it means that I've got a bigger degree on bottom, so it has horizontal asymptote y equals 0. And greater degree on bottom, automatically y equals 0. All right, so how would I say, characterize these by their end behavior? This has a y equals 0. This looks like it has an end behavior y equals 1. This probably has a slanted asymptote. So that's going to be bigger on top. The degree of n would be greater than the degree of d. Okay. Yeah, I'm going to take this problem a little farther. This one has a parabola-shaped asymptote. I don't even know if you can say if asymptote is the right word, but it's got a parabola-shaped end behavior. All right, so what I am going to say about this is that for y equals 0, that's my right answer. That's where the degree of the denominator, so I would say the degree of d is greater than the degree of the numerator, which is what they told me. They told me that the degree of n is less than the degree of g. Okay, on this one, I can say this one's bigger on top by exactly 2. So the degree of n equals the degree of d plus 2. Okay, that's going to be for sure. And a slanted asymptote is when I'm bigger on top by 1 factor. So the degree of n equals the degree of d plus 1. Okay. I don't think I've ever used that notation to denote the degree of a polynomial in precalculus algebra 2, but it seemed appropriate right now. Oh, and y equals 1, that's where they're going to have equal degree, right? It's because of the horizontal asymptote being the ratio of the leading coefficients is going to be 1. All right, so degree of the numerator is equal to the degree of the denominator. Okay, and that's, I answered the question quite a while ago, but I think that's, I could intuit things about the leading coefficient because the slope of that thing's positive, or because the parabola on B is opening up. I could say that leading coefficients of n and d are either both positive or both negative. But I think that's about all I can say about those things in general. So I'm going to move on. Number 7 says, here's another rational function r. For which of the following values of x does the graph of r have vertical asymptotes? Okay, so vertical asymptotes, remember, those are things that are left over in the denominator after cancellation, after canceling off everything that can be canceled. So if I was to cancel off 1 power of x plus 1 and 1 power of x minus 2, I'd be left with r of x equals x plus 1 once, no x minus 2, and an x minus 1 over x and x minus 2 squared. Okay, vertical asymptotes, those are going to be the leftover zeros of the denominator after canceling, so 0 and 2. Ooh, I would have liked an answer choice E that said 0 only, because I could see somebody thinking that like the squaredness made it not a vertical asymptote anymore. It does make it still a vertical asymptote. It just means that the pieces of graph sit together, either both positive, going towards positive infinity, or both going towards negative infinity. Sometimes called togetherness, but probably not by me. I had something else. Oh, I was going to say at x equals 2, there is a vertical asymptote because it's left over after canceling, just like I said all along. But at x equals -1, there will be a hole in the graph, and the impact of the fact that there's still an x plus 1 in the numerator is the y-coordinate of the hole. That's going to place the y-coordinate of the hole at 0. Okay, but that's not what they were asking. I just thought I should mention. So here we've got vertical asymptotes at 2 and 4, so they need to be 0. So the denominator, you know, you can go and factor, I guess it's x squared minus 6x plus 8 repeatedly, and that's going to be x minus 4 and x minus 2, so... Okay, so that's something that has zeros at 2 and 4. We're looking for having vertical asymptotes there, zeros of the denominator, that's great. Okay, x squared plus 6x plus 8, that would be, if you made a factoring error, like an algebra error, that one's out. X squared minus 6x plus 8 in the numerator, that's no good. That would have zeros at x equals 2 and 4. And D is, you know, doubly wrong, so I think that I'm going to just leave that one there. Okay. All right, this one I think intended to allow the use of a graphing calculator, but I think that's kind of silly because I think some graphing calculators can show you the location of a hole. I figured the numbers were distinct enough you'd be able to figure it out without a calculator, right? So we can just figure out based on, you know, number sense. So y value the coordinate of the hole. Okay, that means we are going to need to do... Oh, that's very interesting. I hadn't looked at this problem closely. All right, first thing I'm going to do is factor out the denominator. Okay, so I'm going to say 2 times -2 is -4, two numbers that add to, or multiply to -4 while adding to 3. Okay, that should be V. Okay, that's going to be somehow 4 and 1, right? Positive 4, -1. Alright, so I'm going to call that 2x squared plus 4x minus x minus 2. Okay, so I'm going to have an x plus 2 times 2x minus 1. Okay, so that would be x equals 1/2, 0.5, and x equals -2. All right, I see. I didn't even need to factor the numerator because I was like, wait a second, that factoring is out of bounds. I do think that you can divide, like you could long divide r of x by x plus 2 and 2x minus 1 separately and see which one actually divided cleanly. But that you are not expected to be able to factor, and I can't even tell. I think that says 4x cubed, but the quality of the snip is pretty poor, and it is not immediately obvious. So, but you know, based on factoring the denominator, I know that a hole is caused by canceling factors. Okay, so it's either the 2x minus 1 or it's the x plus 2, right? I only see one of the zeros of those factors in my answer choices, so I guess I'm going to have to go with -2. I am going to verify that, though. Oh boy, yeah, that was exactly what they wanted me to do. Okay, I did not read the question closely. We are asking for a y-coordinate of a hole, so there's more to this thing than I had thought. Okay, what we're going to need to do is we're going to need to figure out which of x plus 2 and 2x minus 1 is a factor of the numerator. And I am not going to long divide the numerator by both of the factors. That's not something I'm going to do because I don't think that's a realistic approach. Another thing I can do is, you know, use the connection between the zeros and the factors, right? If x plus 2 is going to be a factor of the numerator, I should be able to plug in -2 into the numerator and get 0. So I do 4 times -2 cubed would be -8, plus 8 times -2 squared. Okay, so I'm sitting at 0, plus -2 minus 3, that's not equal to 0, so that's x plus 2 is not a factor. Okay, so I got to assume the factor is x equals 0.5. And I actually know that because I went to Wolfram Alpha and asked it to factor the numerator for me. And much to my disappointment, I found that I had bubbled the wrong answer. So x equals 0.5, and we can just check this. If I cube 0.5, I'll get 1/8. Plus 8 times 0.5 squared is 1/4. Plus x is 1/2, and then minus 3. So I'm just going to kind of collect some things. I've got 4 halves is, no, I was looking at the 8 over 4. Okay, 4/8 is 0.5. 8 over 4 is 2. Plus another 0.5 minus 3, that's equal to 0. All right. So I guess maybe I was supposed to divide by 2x minus 1. I don't know about this problem. So we're dividing by 2x minus 1, and we're going to say 2x times 2x squared is 4x cubed. So that's 4x to the 3 minus 2x squared. I subtract that. 4 minus 4 is 0. 8 minus negative 2 is 10. Drop these things down and ask myself, all right, what am I going to multiply 2x by to get 10x squared? That'll be 5x. And then I multiply that by the 2x and the negative 1. And I subtract 10 minus 10 is 0. 1 minus negative 5 is 6. And then, okay, I did expect it to divide cleanly. So I have 2x minus 1 times what is 6? That's 3. Okay, so what I can do is I can rewrite r of x equals, a simplified fraction would be 2x squared plus 5x plus 3, the leftovers from the numerator, divided by that other factor of the denominator. I determined the denominator was 2x plus 1, that would be x plus 2. Okay, so the location of the whole is I'm going to plug in the x coordinate of the whole, which is x equals 1/2, to r of x, and get y equals 2 times 1/2 squared is 1/4, plus 5 times 1/2, plus 3 over 1/2 plus 2. Yeah, that's right. Okay, so that's 0.5 plus 2.5 plus another 3 divided by 2.5. So it looks like 6 over 2.5. Okay, so that's 6 divided by 1. Dividing by 5 halves is times 2/5. So that's 12 over 5. And so that's going to be 2.4. That was a serious problem there. All right, this next one's going to ask us to reason about a function's properties near a hole in its graph. All right, which of the following statements is true? Neither of the one-sided limits is defined. That's untrue. Okay, I'm going to just go back and remind you of what they're meaning by a one-sided limit. In red means that, okay, I can get as close as I want to that hole, right, as I approach from the left. So I'm going to say the limit as x approaches 1 from the negative side of r of x is equal to 1/2. Then from the right, I'm approaching that way. And the fact that it's an open circle, no, I didn't want that to happen. The fact that it's an open circle, that means I can get as close to it as I want. So limit as x approaches 1 from the positive side of r of x is also equal to 1/2. Okay, so because it said that neither of those limits is defined, I'm going to eliminate both of them. So it says both of them are defined. Okay, we agree on that. These limit values are not equal. No, they are. They're both 1/2. Okay, so that one's out. These limit values are both equal to the limit of r of x as x approaches 1, which is equal to 1/2. The fact that the two one-sided limits exist and agree, and that's the definition of a limit existing, I personally feel like that's more AP Calculus than AP Pre-Cal, so I'm just going to ignore that. The rational function r is given by this formula. Which of the following input values corresponds to a hole in the graph of r? Okay, we need to factor it, find the common factors, and cancel those off. I'm factoring out an x squared, and I'm left with an x squared minus 1, so I'm going to be able to keep going. Factor out an x, left with x squared minus 2x plus 1. This is x squared times x plus 1 and x minus 1 divided by x times x minus 1 squared. Oh, I like where they're going with this. This would have been a good test question. Okay, so I can cancel off 1 power of x there. And the fact that, and I'm also going to be able to cancel off 1 factor of x minus 1. That's very important. And the fact that, and I'm going to actually rewrite this so you can really clearly see what I'm left with. That's an x times an x plus 1 over x minus 1. Just as long as x is not 0 or 1. Okay? X is 1. None of these things are defined anyway. So what I'm saying is that the vertical asymptotes are what are left over in the denominator after cancellation. So x equals 1, that's a vertical asymptote. So I'm going to eliminate all 3 of these because we're talking about a hole in the graph. That's x equals 0 only. Okay. Now, the fact that there's an extra x left over in the numerator, like I said earlier already in this problem set, that's going to cause the y-coordinate of the hole to be 0. It's going to cause the location of the hole to be on the x-axis. I think that's all I'm going to say about that one. Okay, here's a formula for f. Notice more of these factorings where the leading coefficient isn't 1. I've noticed that quite a bit on the personal progress check, but less so on the items we're seeing in AP Classroom. So I'll let you make of that what you will. In the xy plane, the graph of f has a slanted asymptote. Which of the following is an equation for the asymptote? Okay, if they want you to find a slant asymptote, we find that with long division. So 2x squared minus 5x. Okay, so this one wasn't factorable, but I'm pretty sure it is, because I think we can think of no, maybe not. 2 numbers that multiply to 6 while adding to negative 5. Yeah, negative 2 and negative 3. So it is factorable, but somehow that's not going to cancel. Okay, so plus 3. Or not, yeah. It's not going to be an identical factor. So I'm going to ask myself, what do I multiply x by to get 2x squared? Maybe a 2x. Multiply that back down, 2x squared, positive 4x. I subtract this, 2 minus 2 is 0x squared. It's negative 5 minus 4 more is negative 9x's. And I drop down the 3 and have that there. Okay, then wait, I don't know what I just did there. Yeah, no, I got way ahead of myself. I'm thinking, what do I multiply x by to get negative 9x? And that would be a negative 9. I multiply the negative 9 by the x, and I get negative 9x, and the negative 9 by the positive 2, and I get negative 18. I'm going to subtract that. Say negative 9 minus negative 9, that's 0. And positive 3 plus 18 is going to be 21. That's my remainder. Okay, but I don't really care about the remainder. If I'm looking for a slant asymptote, that's what I'm seeing up here. Y equals 2x minus 9. That's going to be answer choice D. Wow, this next one, I wish I had seen this. 100 liters of water and 5 kilograms of sugar were added to an empty mixing tank to make sugar water. All right. Concentration of sugar water in kilograms per liter in the tank at time t minutes. Okay, so we're going to really let the units guide us here. And I will say that I have not seen any problem like this in AP Classroom besides this one. Right? We definitely base the test off of what we can see in AP Classroom. So I don't think you need to worry about this as far as the test goes, but this is just a good problem. If we're looking for an expression for C of t, which is going to be measured in kilograms per liter, it's going to have to do with something in terms of kilograms in the numerator and something in terms of liters in the denominator. Okay. Now, 100 liters of water and 5 kilograms of sugar, okay, 5 over 100, were added to, so we need to probably add that to something to make sugar water. additional water is added 10 liters per minute, and additional sugar is added, I mean, I assume simultaneously at a rate of 2 kilograms per minute. Yeah, so we're going to need to shorten up that fraction. See, we're starting with a concentration of 5 over 100. And then at each time t, we're adding 10 liters per minute, so 10 times the number of minutes. Yep. Divided by 2t here. Is this even legitimate? Oh, yeah. Okay, that's fine. Oh, but I did the liters over the kilograms. Yeah, that's classic error. Okay, so the number of kilograms is 2 over number of liters is 10, but these are going to be multiplied by t. Yeah, because we're just doing the total amount. But no, we're not going to just add those separately. Yeah, because you wouldn't add it. You have to think about the total amount of water in the tank and the total amount of sugar. I haven't worked a problem like this one in a long time. Yeah, so I'm going to want these under a single fraction. If you are interested in this problem, you should come talk to me. I'd love to work this one with you, but not just like right before the test or anything. 5 plus 2t over 100 plus 10t. I'm thinking about this, and that seems more like it. Because the numerator gives the total amount of kilograms at time t. The denominator gives the total amount of liters at time t. And that's how we get the concentration, is dividing the total amount of kilograms by the total amount of liters. Wow, this has been a tough problem set on me. Alright, now we're getting back into what I'm more comfortable with. Here's a rational function. It's already factored for you. It's graphed in the xy plane. Determine equations for all vertical asymptotes of the graph of t, or state that none exist. Alright, so vertical asymptotes are going to be everything that's left after cancellation. So I canceled off x equals 1, so that means there's going to be a hole in the graph of t at x equals 1. I don't like how they're using t as a dependent variable here, but you got to be ready for that type of thing. There's no rule out there, no law saying that you can't use t as a dependent variable, that t has to be an independent variable. So I've got a hole there. Vertical asymptotes of the graph of t are zeros of the denominator that are left over after cancellation. So I'm going to have x equals negative 3 from that factor. I'm going to have x equaling 3 from that factor right there. And I'm not going to have anything from that 5 right here, right? Because 5 can never equal 0. I'm not going to have x equals 5, I'm not going to have x equals 0, because if I plugged those x values into the denominator, I would not get 0 back. Okay, so those are the equations of my vertical asymptotes. Find all real zeros of t. Okay, zeros of t are the zeros of the numerator that are left over after cancellation. So that's either x plus 2 equaling 0, or x minus 4 equaling 0. That would happen when x was negative 2, or when x was positive 4. All right, part C asks if the graph of t has any horizontal asymptotes or slant asymptotes. Write equations for these asymptotes, or state that no such asymptotes exist. Give a reason for your answer. Okay, well, that's never going to be the case with a rational function. It's either gonna, I guess, maybe if everything canceled off perfectly and you just had like a line with a bunch of holes in it, or a parabola with a bunch of holes in it. Or I guess if we were bigger on top by 2 or more, we'd have like a parabolic situation. They wouldn't ask you for that. But I'm seeing what's left over. I'm just going to try to copy it. X plus 2, x minus 4. Divided by 5 times x plus 3 and x minus 3. Okay, if I was to distribute this out, I would have x squared, and other stuff. I could easily find it, right? But I don't need to, and that's kind of my point here, is the denominator would be 5x squared plus other stuff. If we were interested in the horizontal asymptotes, we would grab the leading terms and say the end behavior of t of x is going to be determined by x squared over 5x squared, which is 1/5. All right, so the horizontal asymptote, that's y equals 1/5. The reason for my answer, I don't know. I know what they want in AP Calculus, but we've never seen how they score it for AP Pre-Calc because we've never taken AP Pre-Calc before. And if I had to just like, if I wasn't sure and I wanted to make sure I got the credit, I would say my reason is the degree of numerator and denominator are equal. And I'm pretty sure, I mean, that's what they said to do in the course description was take the ratio of the leading terms and let that determine what your end behavior is. Um, you know, and I might say the limit as x approaches positive or negative infinity of t of x is equal to 1/5. I feel like that's got to be reason enough, right? I feel like I've said a bunch of things that are true, and that's all the cause of the horizontal asymptote. So I'm just gonna leave it there. All right, I forgot. Actually, we can go back. I've found we can look at the scoring guidelines in the personal progress checks, and so what it says is a student response needs to include both of these criteria: y equals 1/5 is the horizontal asymptote, and no other horizontal asymptotes, and a reason that references the degrees of the polynomials in the numerator and denominator of t. And the model solution has a lot of writing in it, and and then a little bit of algebra that's a lot like what I showed over here, 1x to the third over 5x to the third. Oh, okay, so they went with the unsimplified version, but that was not necessary. Yeah, and I said degrees of numerator and denominator equal. Okay, so I'm sure that's what they were looking for. Okay. But it did say it was 2 points, and it's one for the equation of the horizontal asymptote, not including any other asymptotes, and then one for the reason. So it's definitely good that we put that down. All right, the next one's going to give us two-factored polynomials and then talk about h, which is defined by the ratio of them. All right, f is graphed in the xy plane. Local maxima and local minima state that there are none. Man, I'll bring in the calculator screen. Okay, let me just maybe simplify this first. H of x is going to equal, and I'm going to need to move this. You can see it when we bring the calculator. F over g. Okay, so these factors are going to cancel, and there's no x plus 3, so it's negative 5 times x minus 2 times x plus 1 divided by 2 times x plus 3. Okay, so we're going to have to find the maxima and minima, and I'm going to set up for that. And I'm going to bring this thing over because I know where the calculator is going to show up. All right, there it is. So I'm going to go to y equals. I'm going to type in my equation. If you've got access to the fraction bar, you should definitely use it. If you don't, you just got to be judicious with your parentheses. I would, actually you don't need to be all that careful if it's in factored form, but just overall with a TI-83, you got to be very careful with parentheses there. All right, so we're going to press graph. And I assume it's just graphing on the standard window. I'm really hoping that we're seeing okay. Okay. I think we're going to need to zoom out. I think there's more of this graph that we're not seeing. Yeah, there it is. Yeah, I had a feeling there was more. Yeah, because I saw there was like a vertical asymptote. It looks like there's a slanted asymptote as well. That makes a lot of sense. There's a vertical asymptote at x equals negative 3. We were expecting that. Slanted asymptote because the degree of the top is greater than the degree of the bottom by 1. And so I'm going to say, all right, calculate a minimum. I see that minimum happening over there. That looks like it's between negative 10 and, I don't know, 0. Ooh, I hope that wasn't bad to go off of the, yeah, okay. Yeah, that was bad to go over the vertical asymptote, right? Because it went with this really extremely negative number, all right? That's good to know. The last time we used the calculator, we weren't dealing with rational functions, so I'm finding a minimum between negative 10, and I will say this time, something a little wiser, probably more like negative 4. Just very close. Okay, yeah, great. And then it's going to find me the x-coordinate of the local minimum. Oh, and it wants the x and y coordinates. Okay, that's interesting. It's different from calculus. Negative 6.162. Always 3 decimals here. And 33.311. Okay, yeah, that's a minimum. And I labeled that as maximum, but I can take care of that. Just change my labels. There's going to be a local maximum. It looks like it's at x equals 0. I'm going to calculate a maximum. I'm going to say between negative 1 and 3. Give it a guess. I'm not gonna I wasn't gonna like an answer of negative 1 because that would have meant that it was like actively decreasing through there, and I just got the left edge, and that would have meant I possibly missed the maximum. If you thought that interval was a little bit too narrow to be totally convinced that you'd trapped the maximum, you could just do it again and just be like, I'll go negative 2. Can't go negative 3, right? Because that's a vertical asymptote. Right bound of 2, that's a definitely wide enough window. I'm going to get the same thing back, right? So I feel good. That's the location of the actual relative maximum. So I get 0.162 and 1.689, or 1.688 if you would prefer to just truncate. All right, and that was calculator. I think that's all of the calculator we'll need. That wasn't even really related to what we're doing in this unit, but it's never a bad time to start practicing the old stuff. So in the xy plane, h has a hole at the point with coordinates c and l. It's known that the limit of h of x as x approaches c is equal to l, and there are consecutive integers a and b for which l is between a and b, where the values of a and b give a reason for my answer. Oh, gladly. So we're talking about the hole. So we had a hole at x equals 4. I'm going to because of the identical factors. So x equals 4, so that's c equals 4. Okay, L is the limit of h of x. So we're interested in the limit as x approaches 4 of h. Now I'm going to use the simplified version of h because that's what we would, we'd get 0 over 0 if we plugged into f and g. And then we would know if we got 0 over 0, we would need to factor and cancel. Okay, over here, negative 5 times x minus 2 times x plus 1 over 2 times x plus 3. Since I've already canceled off the x minus 4's, all I need to do is plug in. So I'm going to have negative 5 times 4 minus 2 is 2 times 4 plus 1 is 5 divided by 2 times 4 plus 3 is 7. So I'm going to have negative 25 times 2, negative 50 divided by 14. I'm going to try to simplify that down as low as possible. That's going to be negative 25 divided by 7. And honestly, if I want to just be like absolutely certain about the... oh, no, never mind. Because it's either way, you just have to think about multiples of 7. I was going to say, if you want to be certain about the values of a and b, you'd have to do long division. Like numerical long division. But, it would be the first step. 7 to 25 is going to be 7 times 4 is 28, but 7 times 3 is 21. So negative 25 over 7 is going to be between negative 4 and negative 3. Which I might label as negative 28 over 7 and negative 21 over 7. Yeah. All right, and so the values of a and b are negative 4 and negative 3. And the work I've shown here is the reason for my answer. All right, determine if the graph of h has a horizontal asymptote or slanted asymptotes. Actually, you might have needed a reason that was saying like why you canceled off x minus 4, and that's the location of the hole. But I'm sure y'all could write a sentence that would work well for that. And that's not something you're going to have to do on the test. Determine if h has any horizontal asymptotes, slant asymptotes. All right, it's bigger on top by 1, so we know it's going to happen. I'm kind of surprised they're allowing to use the calculator on this because I know some calculators can just do the polynomial long division. So -5, I'm going to have to distribute it out. So I'm going to just actually grab the thing and bring it down. Right. If I need the end behavior, I want to have it in standard form on top and bottom. Let's see, 2x plus 6, and then I would keep going, -5. And, if we want the end behavior, we know that, oh no, it said find the slopes for these asymptotes, so we're good. All we need is the end behavior. Okay, so we look at the end behavior. We take -5x squared over 2x, and that's -5/2 of x. Okay, we know that the slope, or that the actual slant asymptote is going to be parallel to the graph of y equals -5/2 x, which, back in geometry, you could have told me that that means the slope is -5/2. Parallel lines got the same slope. So we know the slope of the horizontal asymptote is -5/2. Slant asymptote, hold on, what was I saying? Yeah, with a slope of -5/2. If I found that I had a horizontal asymptote, I would report that the slope was 0 because the slope of a horizontal line is 0. All right, and that was the last problem. That's going to be all I got for you in this video. Thanks for watching.